There are so many variations across the country about what the grid looks like. We're excited about some of the new technology. Renewable energy is coming on. There's a lot of solar, and those are changing the way the grid is operated.
This is EnergyCast, and I'm Jay Dowenhauer. Today we are talking about the future of the transmission and distribution grid. Many of you know I work in the transmission sector as a project manager in my day job, and this is the first proper transmission episode. What I can tell you is that the T&D sector of the energy industry has never been hotter. Utilities around the country are spending more than ever before on the grid. A lot of it has to do with the rise in renewables. The grid has to adapt to the input from thousands of generation sources rather than a few large ones. Cybersecurity is also important. You look inside some of these substations as I have, and some of the relay and control equipment would be familiar to your grandparents. For a lot of this equipment, time's simply up. I love looking at the nameplates on old transformers and breakers in the field, with manufacture dates going back to the Kennedy years sometimes. You have to wonder how much history, social, and technological change this equipment has seen. And, my personal opinion, it makes safe business sense for utilities to invest in this family of infrastructure. Utilities make money on capital cost recovery. Essentially, they spend money, they make money. As I've asked guests in the past, would it be easier to build a transmission line or a power plant? It's usually easier to build the transmission. I've wrestled with doing a transmission episode for a while now on this podcast. Don't want to bring my work too close to my hobbies, you know? But while rushing from the recording you are about to hear to another presentation I made later that day, I told our session sponsor I didn't think transmission was as dynamic or as interesting as the other topics we explore on this podcast. I know it's a flawed line of thinking, but I figure, hey, if I'm familiar with the subject matter, how is that interesting to all of you? But after listening to the conversation we had that day while cutting this episode, I'm convinced that we're living in a grid golden age. My episode this week is my second live episode, recorded in San Antonio earlier this year at DistribuTech, one of the biggest transmission and distribution shows in the country. I was approached to do a panel after I spoke at the PowerGen show in New Orleans last year. When asked what topic I wanted to explore, I said, how about we program against all the talk about microgrids, distributed generation, and essentially this argument that utilities are becoming less important? It's a little self-interested, I know, but I strongly believe that we will always need a big grid, pumping out hundreds of kilovolts to our hundreds and thousands of communities around the country. But I also wanted to explore our opportunities. What, as a project manager, will I be putting into service over the next few years? What sectors are underserved and need to be built out? For the panel, I sought out representatives from two companies I work with regularly, Siemens for our hardware and HDR for engineering. I got two fantastic guests, George Belovic with Siemens and George Culbertson with HDR. The session lead was Ed Thomas with the Peak Load Management Alliance. I hope you enjoy my panel from DistribuTech in San Antonio.
Thanks, everybody, for joining us today as the excitement continues to build here at DistribuTech 2020. I'm Ed Thomas, your chair from Peak Load Management Alliance. We are going to have a question and answer period afterwards, so be thinking about any remarks you have, and we'll come out in the audience and give you an opportunity to ask some questions. With that, I'm going to turn it over to Jay and let the session begin.
Thank you so much, Ed. Good morning, everybody. My name is Jay Dowenhauer. I'm the host of the EnergyCast podcast, and to date we've produced over 75 episodes with guests from all energy sectors. Now, that's been very important to me, acknowledging that the conversation doesn't begin and end with renewables and climate change, which is very important, but it's also oil, gas, coal, nuclear. It's energy storage beyond batteries, and it's a robust and modern energy grid capable of transmitting hundreds of kilovolts at a time of power around this country. And that's what I want to focus on today. The fact that we still do the big stuff stuff, and we are getting the opportunity to expand our big, beautiful grid unlike any other time in maybe a couple of generations. We'll be talking about that with our guest today. So we have our two Georges here. George Belovic, Vice President of Energy Solutions for Siemens Digital Grid, provides advisory services, smart grid strategy, and grid modernization to customers. And then we also have George Culbertson, closest to me. He is the Vice President of Global Power Delivery Markets for HDR. He provides project management, client relationship management, and technical services for utility and industrial clients in HDR's power practice. So, my first question, I'm going to present this thesis for the panel, okay? I believe we are living in a grid golden age, and utilities are spending more on upgrades and expansion now than any other time before. How do we feel about that, guys?
Jay, thanks again for inviting us. And when we talk about the golden age, you've got two golden age veterans up here to talk to the audience, so appreciate that observation. We see significant investments happening in the utility industry right now across all sectors. The transmission network in particular is being expanded to be able to recover and connect those sources of renewable energy, our big wind sources in the upper Midwest, and connecting them to the load centers in the East. So we're seeing a lot of utility investment in the transmission space right now and in those renewable sources.
Yeah, Jay, I would have to take a little exception to the fact that this could be the golden age because I think there's a lot of improvements that need to happen. Although the transmission spending has been steady and peaked at certain times, especially in Texas with the CREZ opportunity for expansion, there's a lot of heavy transmission in this country that's been kind of stalled due to permitting issues, regulatory hurdles to jump through. I think it could be a lot better. There's a lot of transmission projects that if we had them in service today, we would have a much stronger grid. Although the spending has been steady, something on the order of between $30 to $40 billion a year in transmission and distribution spending over the last 4 or 5 years. Those investments will continue, but we still need to have a more resilient and sustainable grid.
That's interesting that you bring up regulatory issues. I think one of the things that I have to deal with a lot in transmission is, especially if you're going over a railroad track, you better plan for that well in advance because that's going to take a little bit of time. But, you know, I did a panel and we talked about transmission issues with the North American Young Generation in nuclear. And I said, hey, how does this compare with power generation? And the question I had for you guys was, are you seeing a shift, especially HDR, George Culbertson, your engineers moving over maybe to more transmission projects because there's a lot of work out there. How does that compare to the generation projects out there? And especially you talk about regulatory issues, it certainly is easier to do, I think, a transmission project, even if it's a big power line, than to build, say, a new power plant, right?
Well, I think there are challenges with both of those, but there is a shift in generation away from coal and even natural gas in some markets. And I think one thing we need to keep in mind when we're talking about the grid in a general, there are so many variations across the country about what the grid looks like and the regulations, the ability to build projects, and the move away from coal, there's a fundamental shift there as the market moves more towards solar and wind and renewable energy. The energy mix is going to continue to change going forward, and the ability to permit these projects, every project has its own challenges in terms of getting things built. We're excited about some of the new technology. Renewable energy is coming on. There's a lot of solar, a lot of DER integration into the grid, and those are changing the way the grid is operated. That's my perspective on that.
Jay, I was just going to comment, we fully support and agree with those points. In fact, if you walked around this floor, you'll see that much of the focus of what we've heard in DistribuTech over the last few days has been on the investment in edge technologies and managing what's happening at the edge. If you haven't had a chance to talk to a DERMS provider or talk to someone who's in the ADMS business, you'll recognize that the challenges for distribution operators in this country to manage all of the emergence of distributed renewable, particularly rooftop solar, and integrate that into their distribution planning capabilities and distribution operations capabilities has become a significant challenge. And many of the vendors on this floor have been talking to our utility customers about how to solve those problems.
Absolutely. I wanted to show this picture. Day to day, I'm a project manager. This is for a series of upgrades we're doing around downtown Charlotte. I think we call it Uptown Charlotte. What I'd like to point out here is that you see Siemens distribution breakers, about 4 of them there, and HDR Engineering is engineering our retaining wall, and that's just a very small part of all the upgrade work that both of these groups will be doing. And one of the things that I always find that's so interesting, and this was a picture I took last week,
week. This project is ongoing right now as we speak. There's a picture here. This is an Allis-Chalmers breaker, and I know it's kind of hard to see, but it has a date of manufacture of January 1967. So it's been in service for 53 years now, and I'm curious, do you think that the stuff we're putting in service now, the work that we're doing now, is going to be lasting into 2080? That's a long time. That is a long run for a lot of this equipment. A lot of it's probably well past its need to replace date, right?
Yeah, I've been in the business a long time, and so what I used to see is very robustly built equipment, overbuilt actually, thicker steel, better copper. The question is, will you be able to get the same amount of life out of the equipment that's being manufactured today, which is being engineered to be as efficient as possible and as cost effective as possible? I'll defer the rest of that to you.
Yeah, great question, Jay. I think today's manufacturers, and again, I'll point to not just Siemens, but many of the folks that are on the floor, are building componentry for the utility system and the networks that actually are much more robust from a control and monitoring standpoint. Our transformers today are shipped with transformer management systems. We've got algorithms and analytics built around our breakers. On the one hand, we are seeing those products optimized from the amount of steel and their weight, et cetera, but we're seeing them operated in environments that actually can extend their longevity because we're much more closely monitoring their performance in the network.
Really excited to know that it's going to be there long after any of us are probably going to be around. We had a chance to talk last week, to kind of powwow on this and throw some ideas around, and one of them I thought was very interesting was this idea about where the load growth is going to be coming from. And I do a lot of work on substations that are customer facing. A lot of that stuff is getting out of date. We'll replace things like capacitor houses and stuff, but what about things like electric vehicles? And in the Carolinas, we're doing a lot of server farms, a lot of things like that. And we talked about this idea of electric vehicles. Let's say that they retrofit a gas station to do high-speed charging. I mean, that is going to be a significant hit on that sector. So tell us a little bit about maybe what you guys are working on to prepare for things like that, this jolt of electricity that we need in these places, and how important that's going to be to kind of make our infrastructure ready for all that.
Yeah, Jay, you mentioned two things for load that really didn't exist just a few years ago. The integration of electric vehicles is changing the structure of the grid and how it's going to be operated. Those loading patterns and how that's going to occur is a big unknown at this point. A lot of studies underway to figure that out better. The data center has a huge amount of growth, exploding all across the country and around the world. The ability to store and manage this data is our digital age that we're in right now. And that's another load that just wasn't around just 10 years ago that we're seeing huge growth in.
Yeah, we've heard some references that the electric vehicle will become the central air conditioner of the next decade. If you think about what happened in the 50s and 60s and the impact those kinds of load made on distribution planning and distribution construction, we think we're going to see that same kind of focus on the impacts of electric vehicles on our distribution system. Fortunately, we like to bifurcate that into two problems, right? The key question here is that what happens if we build big centralized fleet charging systems, or they start to approach the load requirements of a big data center? We tend to handle those like very large new load additions, and we probably follow the same distribution engineering standards and approaches that we've done in the past. But residential charging in the home, when a customer can just go buy a charging station and put it in his garage, level 2 charger, and plug in their Tesla or their Chevy Volt, we're seeing those charging systems make a significant impact on distribution, and the ability to communicate with those using some kind of an operating system and software product that allows a utility to provide to that customer a rate that suggests you just came home from work at 5, you don't need your car again until 8 in the morning, it only requires 4 hours to fully charge. If you give the utility the ability to decide when that 4 hours worth of charging occurs, we give you a special rate than the one you'd pay if you just plugged your car in when you got home, right? And the ability to control charging and monitor that over a broad ecosystem and a broad geospatial deployment of these vehicles, I think, is a challenge I think we'll all be working to solve over the next few years.
That's interesting you're bringing up the distribution side of that and these things happening in the homes. I mean, say my neighborhood back in my hometown of Bossier City, Louisiana, what if they all go electric? Is the distribution infrastructure prepared for that?
Yeah, I think what you'll see happening is the distribution system operators make the same kinds of distribution investments in the next few years that they made in the 50s and 60s as the residential load shape changed. And as those residential chargers emerge and become a significant part of the load in a residence, managing those residential chargers and essentially doing the distribution planning to anticipate these kinds of load growths, I think will become commonplace in the industry in a few years.
But there's also an opportunity for two-way load flow there. So you could actually pull from those vehicles that are sitting there not being used and actually bring energy into the grid when you need it. So there's some very exciting developments that are still trying to be worked out technically there. I think one other perspective I'd like to add is that from our perspective as an engineer, we're seeing a lot of interest in the heavier charging for fleet electrification is a big thing going forward. Moving goods and services across the country using electric vehicles is a big potential impact on greenhouse gas emissions, and I think we're going to see a lot more emphasis in that, as well as just moving people around.
Right. I love vehicle to grid. As far as lithium-ion batteries and using batteries, that's one of my favorite things because you already have the batteries. Those cars sit still, I think it's 95% of the time, so why not use a little bit of all those batteries that are just lying around? There's been a lot of talk at this conference about microgrids, moving away from large transmission projects. I like to counter-program a little bit and say that no, utilities are still in the business of multi-million-dollar high-voltage projects. I went out, this is the largest project we're working on. It is a low nine-figure tie substation in the middle of North Carolina, Greenfield. Look, I mean, we still do the big stuff. What have you seen? I mean, we're still putting out some big iron out there.
You know, we had a chance to talk about, I'd say, the reformation of the electric grid when we were on our call last week, and I had a chance to speak at a conference last summer where actually the title of the conference was, Will the Electric Grid Become Irrelevant? And I think you start asking some fundamental questions about what that really means. We use the example of, what if you had the opportunity today to just wipe the slate clean and start all over and essentially rebuild the electric system using the technologies that we've all seen here at Distribute over the last few days. And we had that opportunity at the island of Puerto Rico. If you think about what the impact that Hurricane Maria made on the island, it literally wiped the electric system clean. And we had a chance to work with the government there to really reform how they're going to operate their electric system. And Jay, to your point, it was rebuilt in a way that we took advantages of microgrids. We called them mini grids. There are 10 mini grids around the island where their generating sources were oil on one part of the island, wind on another, solar on another. We allowed those distributed generating sources to actually create mini grids of their own, yet waited for the transmission interconnection to be reconstructed so that you could actually leverage the benefits of a fully integrated transmission network that increases reliability, allows you to distribute costs across your customers based on those fairly diverse sources of generation and cost. So I think if you rebuild today's system, I think it would be a combination of generation closer to the loads for resiliency purposes and transmission to basically manage the reliability that we've enjoyed in this country for years.
Yeah, but I don't think you're ever going to get away from a backbone grid because of the ability to have power flows all the way across the country with different load peaks and things like that. My whole career has been about building transmission, so maybe someday, maybe we could get to that where you don't really have the need for all that steel and wires, but certainly within my lifetime, we're going to continue to need high voltage transmission.
You bet. So I'm just a lowly project manager. I basically get told the project I push 10. I don't sponsor the project. So help me out here. What do you think I'm going to be working on in the next 5 years? Look, I'd love to be putting grid banks out at substations. We hear a lot about that. I haven't had a chance to do that yet. We talked a lot about the electric vehicles and building these new substations to handle a lot of that. What other things other than replacing breakers, transformers, upgrading circuits, what do you see coming down the line in, say, the next 5 years?
We've seen some projects on campuses emerge where the traditional sense of every single load on that campus, or whether it's a commercial office park or a large residential or planned unit development, where every single building on that piece of property is individually metered, individually served from all the utilities, gas, electric, water, et cetera. We're seeing a movement in some parts of the country where we're having planned unit developments where on-site generation and utility service gets aggregated, and we provide energy as a service to the folks that occupy these areas. And so when you ask what will I be working on in the future, I think it'll be an exciting mix of delivery from the utility and on-premise generation served in ways that we haven't thought of before. We worked with a university in North Carolina recently that actually replaced a 70-year-old oil-fired boiler that provided steam to their buildings on campus. They moved to a cogen solution that allows them to generate a significant part of their electricity as a byproduct of making steam to heat their buildings. I think we're going to see those kinds of sort of multi-utility services emerge over the next 5 to 10 years. I think it'll really start to reshape what our utilities will be working on.
Yeah, I agree. Combined heat and power for those type of campus solutions are definitely worth considering. But again, as a high voltage transmission guy, one thing that I'd like to see more of is HVDC to interconnect these large distances efficiently, provide a very stable backbone to allow energy flow where it's needed. There are some good HVDC projects in the country, some under development still. I think it's also a solution where you can increase capacity on an existing transmission line by converting to HVDC.
Yep. We're going to take it out for questions. Ed, do you want to start?
Sure. If you've got any thoughts, I'll get it started here and then going to turn it over to you guys. What about high voltage DC transmission? Is that in our future in any horizon that you can see?
Absolutely. Canada has a number of HVDC systems. We have a few in the country too, especially out in the West. It's a very efficient way to transmit power over very long distances. I expect to see a lot more of that. There's a place for HVDC in the future grid.
I'll keep doing this, but no, go ahead. Tell us who you are.
Yeah, I'm Michael Gray with Energy. Vehicle to grid. I heard a lot of discussion about vehicle to grid, but do you really think that's practical, since anytime you discharge a battery, you induce some wear on the battery, so you shorten the life on the battery? And vehicle batteries are expensive. You know, the lithium-ion batteries are expensive. Even though the price is coming down, they're still expensive. So you're putting wear on the customer's product. I just can't see the cost benefit there to discharge somebody's car to help support VARs on the distribution grid.
I'll actually take that question. So I drive an EV today, and a plug-in EV, and my manufacturer does not enable the vehicle-to-grid connection from the battery in the car for that very reason. And it's an inline hybrid. My car's 6 years old, it's 115,000 miles. I think the new versions of these vehicles that are coming out and the new generation of these lithium-ion batteries that are emerging will allow them to actually be used in vehicle-to-grid applications. So we're going to see vehicles in this country soon that will allow this reverse flow of energy out of the battery into the home. I mean, it ticks me off when I'm sitting in the dark because there's been a power outage and I've got a 16 kilowatt hour battery sitting in my garage that I can't use. So I think the consumer demand will drive that.
Yeah, I can see an individual consumer might want that as the option as a backup power source for their residential application. But to help out on VARs on the distribution grid, man, you better pay me if you're going to discharge my car to help out on the distribution grid.
That's exactly right. Utilities would have to create an incentive for them to use the batteries that customers have in their garages for VAR support or the kinds of things that you're talking about. And I think rate structures will evolve to enable that outcome. I mean, customers will be in a position to decide whether or not they want to subscribe to a program that allows their vehicle battery to be discharged to support load VAR support on a distribution feeder or not. You're right. It's going to be driven by customers.
I did an episode on vehicle to grid with the only commercial company that's doing that right now, which is Nuvve out of San Diego. And they talked about that. Basically, they would have a compensation model if you are tying in and for vehicle to grid. And there's another company that I talked to out of Charlotte. I'm hoping to have them on the podcast soon. They're called Phoenix Power. They're doing a subscription-based lithium-ion battery model. So basically, your first battery bites the dust. You pay them a subscription fee, and they just handle the battery. If it wears out, you get a new one. You can even pay for capacity. So you might not have the full capacity of the original car. You can pay to have less if you want it. So really exciting business model there.
The Battery of the Month Club. Go ahead, over here. And just tell us who you are.
Yeah, I'm actually Jasper Dorndorf with HDR Engineering. What are you seeing besides small electric vehicles? What are you seeing the next stage of EV transformation? Ships, cargo, ferries? What are you guys seeing at your high point right now?
We call them non-road applications. I think there's going to be a significant growth in non-road applications of electric vehicles. So think of the tug that pulls your airplane away from the gate at the airport, the mail truck that runs through the neighborhood. That's a road application. Forklift trucks in warehouses that are today run on propane. I think there's significant advantages to converting that non-road fleet to electric charging. We're seeing that happen all across the market.
There's even a pilot airplane, commercial airplane. Can you imagine flying around in a drone? From point A to point B. They're working on those now.
What about new technologies in the control house? We talked about end use, grid edge, but take us back to the control house. Anything new going on there?
Over my career, there's been a lot of change from electromechanical relaying to the more digital relaying. And the advantage there is you can upgrade your software with the same box. And that's a real advantage. As software developments occur, those improvements can be pushed out. I could just see that being a continuation of the advancement in technology, even with some of the existing hardware, the software is where the future could be there.
And Jay made a great point earlier that some of these substations we're seeing utilities replace are 50, 60 years old. And we're seeing entire fleets of substations get replaced over the next 5 to 10 years. But I think utilities will have an opportunity to really rethink their protection and control schemes that are in those substations and account for things like the impacts of EMP on the performance of these stations. In our booth, we had a chance to talk about how an EMP-resistant relaying environment in a substation that can use less relays and be focused on EMP protection and resistance, it will become a commonplace component of the substations of the future.
That's really exciting, the EMP stuff. Most of the control houses that we work in look like some sort of nuclear bunker from the Eisenhower era. So I think we're going to wrap it up. If anybody has any other questions, but I want to thank both George Belovic and George Culbertson for their time. I really appreciate your insights and everything. Thank you so much for coming today. Let's give them a big round of applause, everybody.
Thank you.
Thanks, Jay.
That was my panel from DistribuTech in San Antonio. I was surprised how much electric vehicle talk we got into. So I reached out to Nuvi, the vehicle-to-grid company I've interviewed in the past, about that question we got from the audience. Nuvi adds that they have conducted extensive aging tests on batteries participating in vehicle-to-grid, V2G, and the additional draw on these vehicles does not prematurely age the batteries below the 8-year warranty offered on all electric vehicles at this time. I want to thank George Belovic and George Culbertson for their time on the panel, as well as Ed Thomas, our session chair. I also want to thank Ellen Dowell and Allison Britt at Siemens, Fernando Garcia at HDR, Brian Paris from CT & Co. for sharing the audio he captured, Mark Trahand at Nuvi for the help with the question at the end, and Debbie Wells and Andrea Harner for setting up this panel. You can find plenty of pictures at energy-cast.com, as well as on Instagram at Host Energy and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. Another milestone, that wraps up episode 80. Be sure to join us next week when we discuss what utilization means for carbon capture and storage. Until then, I'm Jay Dowenhauer. We'll see you next time.